Okay, so properly refreshed now. Oh, excuse me. Um, what we're going to do here is look at a different way to filter through the information of a list. Okay, and we're going to use some mathematics for this. It's a feature that's called larger than, or you can do smaller than, but it's all listed under the math tab under operators. Okay, so under operators, there's this really cool one called larger than. And larger than is going to be pretty powerful for when you have an output like this that gives you an index value that's not Boolean, right? So it says it's either outside or it's coincident or it's inside, right? So you got zeros, you have ones, you have twos. We probably don't have ones. Ones are going to be extremely rare. But nonetheless. Anyway, so we've got these numbers. If I drop a larger than in, let's read its description. So it says, well, it doesn't really describe much, but read the description of what the input is. So first number A is the number to test, right? So that's going to come in as a list, right? We're going to test all of the numbers of our list for whether or not it is a 0 or a 2, right? So is it inside or is it outside? And then B is going to be the number to test against. So if we're trying to figure out if we have zeros or twos, if I put a 1 to test against, that means all of my zeros are going to read as less than. All of my ones are going to read as greater than or equal to. Or I'm sorry, my twos, greater than or equal to. So we've got larger than and then or equal to. Less than or equal to. Anyway, so here's the...
Should we make item?
I'm sorry?
Should we make item?
Item? No. No. Because we're trying to get all of the items of a particular type.
Oh,
not just one item. Okay, so here's what we're going to do. When we plug in the list of the relationship list, we will test against the number 1. So you could do that with a param down here, or you could do it with a panel. I'm kind of getting really into the idea of using panels lately. So I'll use that, and I'll plug it in here. And so here's our output. What that gives us, very cleverly, is a Boolean output, which is what we want for the cull pattern. Making sense now? Yes, no, maybe so? All right. So we will use that Boolean pattern to cull the next pattern to remove some of the circles that are included in the pattern. Dispatch. I don't want dispatch. Okay, so it's really as simple as just taking the cull pattern and making another one, except the pattern now is going to be the same list of circles.
I have a question.
Yes.
So we picked the 1 because we're showing that 1 is going to be coincident, right? It's not inside. What's the number 1?
I don't understand the question.
Why
So
we picked the number 1?
we picked the number 1 because we want to separate the zeros from the twos. So if it's larger than 1, you kind of have to be on the fence with the number 1, right? Because if you happen to have one that is coincident with the line, which is extremely rare, then you're gonna have to choose whether or not you want to test if it's greater than 0, in which case your ones are going to be considered included, or if you want to test if it's greater than 1, then anything that's coincident is going to be excluded. You don't get it? I'll explain it to you a little bit later on. So let's get back to this real quick though. So I have a cull pattern, and actually I noticed I'm going to have a mistake here, but let's work through it. So I need to cull away some of the circles from this cull pattern. So that means that this one is going to get a new list, and let me just disconnect everything so you can kind of visually see it. The list for the cull is going to be the other cull, because now I'm taking the ones that I took out, and now I'm taking out more. And the pattern is going to be this Boolean list. Everything that is larger than 1 in that list is going to be included, because it comes up as true, and anything that is a 0 or less than 1 is going to be excluded, because it is outside of the volume. So I plug that in, and it's going to give me an error. And it looks like that. So why do I have an error? So let's trace it back. Okay, so now I'm doing troubleshooting, right? It did not give me the expected response. I need to figure out why. So I start with where the problem occurred. I review what the input values are to make sure they sync up. And what I notice immediately is that the list that I'm culling with has 183 values. The list that I'm giving as a pattern has 256. Does anyone have a suspicion as to why that might be?
Has the same number as.
You might not have exactly the same numbers, but theoretically you should have a difference between your two numbers. Why would they be different?
The first call was like all the circles, and then the second one is the only ones inside that curve.
That's correct. Absolutely correct. So if I trace back where there are 256 of these, right? So I've got 256 going into P, 256 there, 256 going into test against the number, which means I fed 263 points, or 256 points into my in-curve test, because I pulled it all the way back from my grid.
It shouldn't be connected grid.
It should not be the grid. What it should be is the center point of each of the circles that I've already culled, because that's where it jumped from 256 down to 183. So I'll need to find the center points of those circles in order to test their points for inclusion. And that's as simple as, let me slide all this over. That's as simple as going to surface analysis, finding the centroid of each of those circles. Notice how it only gives me a centroid for the ones that exist, or that remain, I should say. And now I can replace the point value into in curve for the test. Now I'll turn this one off. I'm going to turn my area off, and I'll turn my cull pattern back on, and now you can see it's accurate. Ish. So I've corrected one part of my problem, right? So now I'm correctly testing the center point of my circles for inclusion. But I now notice that while I'm correctly excluding everything that's outside of this surface, I have circles that are larger in radius than their proximity to the perimeter of the curve. Am I throwing out too many words there? Okay. So, like I said just a second ago, right? I realized that my circles have a larger radius than their center point's proximity, meaning distance, to the perimeter of the curve. So if it has a larger radius, that means that the arc of the circle is going to reach out beyond the perimeter, and I don't want that. So I stated it using very specific words and vocabulary, because we're going to use that vocabulary to correct that problem in the next step. So what questions do you have? Okay, so I imagine that hopefully most of us are here and correct, but there may be a few of you who are not. So I'm going to come around and get everybody on the same page before we start, streamlining this definition.